Today I would like to introduce you an important concept in Scala named expressions and compare them to their counterparts, which are instructions. For demonstrating expression, let me define some variables here. So for example, I would like to define variable x with the type of int equal to 5 and also variable y with the type of string equals to hello Scala and Spark, and variable z just type of double equals to, I would say, 5.5. If I write x plus 1, then this is an expression because it contains a value of 6. Or if I write, for example, x equal to z, should raise an error because the type of the variable x and z is not equal. I need to define a new variable y here, like for example type of int and the value of 10, and just tell that x equal to y and the value is false. So this is also an expression. Equals is also an expression. Let me demonstrate this expression by writing a code block. For example, if I define a code block to test if a number is even or odd, then we can better understand the concept of expression. So for example, I can write val even or not, which checks if a number is even or not, and then create a curly bracket and write val x equal to, so I would like to generate a random number. I can use a scala.util.random next int, and I generate a random number. It's a code block because it contains this curly bracket, and I just shift enter. You can see that the outcome is a unit, and this unit, it means that this statement didn't return any value. So I would write here unit type shows that the statement didn't return any value, or it doesn't contain any value, and it's like void in other programming languages. So let me copy and paste here just to make a copy, and here I would like to return a value for this code block. So if I write x here, just x without any operation, you can see that the type of this block has changed to int, from unit to int. So it means that this x itself is a statement. So if I write x plus 1 here, you can see that the whole block is evaluated as an int. The value of a block is always evaluated by its last statement. So here we have x plus 1. So this makes the whole block as an expression because this even or not will contain a value. If I write, for example, if x divided by 2 equals to 0, because I want to determine if it's even or not, then even, else odd. Then if I hit enter, you can see that the block will get a type of a string, and it shows that the if statement is also an expression. So I'm writing here if statement is also an expression. If, for example, I write another statement or expression here, like the remainder of x by 2 equals to 0, return 1, else 0, then this whole block should be evaluated as an int because this is equivalent to the value of the last statement. Shifting enter, and then we can see that it's int here. As mentioned before, reassignment is not expression. So if I comment out these two parts, you can see that the block will get the value of unit. Or also if I write print ln, then this whole block should also have the value of unit because print ln is an instruction or an order, and it's not an expression. Let me extend this example by writing another function or a block. For example, here I'm writing like another block of code, something like test, and I just copy and paste this line of the code, want to define a variable y, and if I write x multiplied by y, then again this is evaluated by the last statement, so it's an expression. I can define a function by using the def keyword, and I would like to define a function named concatenate string, and this function receives an input, and I would like to name it first and type of a string, and also another input, second type of a string, and it returns an output because a function receives an input and then returns an output. And for defining a function, we use the equal sign. Here the function just wants to concatenate the two strings, like the two input strings. We use the plus sign for the concatenation, and we can write first plus second. Of course, we can concatenate two strings in Scala by using first concat second. And this should work as well, and it's working. Let me test it here. This is working, right? This is working also correctly, but we could just simply write first plus second, and this is as well fine here. In other programming language like Python, we can write return, and also of course in Scala also we can write return. But there is no need for doing that, because understand the last statement of a function as its return value. So because it's sort of an expression. So if I remove the return type and I just define this function within a code block, this function creates this unit in this block. To call this function inside this block, so I use concatenate string, and I give two inputs to this function like hello, Scala, and Spark. And you can see that now the code block has a value of a string, which shows that I'm writing this here, calling of a function is also a string. Okay, to give you an example of what are not expressions, I would like to define a for loop here. So for defining a for loop, you can write for, and I'm defining a variable here, which is, for example, a. It can do iterations from 1 to 10, and I'm writing that just return a value of a, just kind of a print a simple for loop. And if I define a variable x, which is kind of a code block equal to this for value, then you can see that it has the value of unit. Because if I just change the print a to a, you can see that the x code block has the value of unit. So because the for is not an expression, but it has the nature of an instruction or a statement, so I'm writing for and while loops are not expressions in Scala. This is very important in big data world. If I reach the discussion of Spark, you can see that these expressions and actions are very important, because whenever we have expressions, they contains values, nothing happens. But when we have actions, something should happen. When we write print, then something should be printed on the screen. For example, when we perform for loop, then something should happen. In Scala and functional programming, in which the big data world is also based on that, we need to write everything in terms of expression. We need to use as much as we can expressions. So like function calls, we should avoid using while or for loops.